So how fractional exponents and radicals are related to each other. And it is based on this idea. You've got your product law. So you can multiply two things together. And we used numbers. So we said, if I know the square root of 9 times the square root of 9 is equal to the square root of 81, which is 9. And I know from my exponent laws that 9 to the half times 9 to the half should equal 9 to the 1. This tells us or implies that 9 to the half is the same as the square root of 9. Does it make sense that you need two square roots to multiply together to get rid of the square root, per se? Like square root of 9 times square root of 9 is just going to be 9. How many cube roots would you need to get rid of something? 3. So if I did the cube root of 3 times the cube root of 3 times the cube root of 3, I would get the cube root of 3 times 3 times 3, which is 27. And the cube root of 27 is 3. What fraction would you need to add 3 times to equal 3 to the 1? What fraction would I need to put here? 1/3, 1/3, and 1/3. Because 1/3 plus 1/3 plus 1/3 is equal to 1. Same thing happens even if you have a fraction inside of the square root. 1/3 times 1/3 would be the square root of 1/9, which would equal 1/3. And here, if you added the exponents, 1/2 plus 1/2, you would get 1/3 as well. So we can kind of summarize this, that anytime you have a fraction of a half as an exponent, it's the same thing as a square root. And then if we expand this, which we've already done a little bit, to cube roots, we find out that the cube root of 5 times the cube root of 5 times the cube root of 5 is equal to 5. And if we use our exponent laws, 5 to the 1/3 times 5 to the 1/3 times 5 to the 1/3 is 5 to the 1, which is also 5. We can say that 5 to the 1/3 is the same as the cube root of 5. And so we start to have a pattern show up. What do you think another way of writing the 4th root of 7 will be? 7 to the 1/4. So any fraction exponent that we have, we can change it to a radical. And any radical that we have, we can change it to a fractional exponent. So we can fill out this chart. The square root of a, or a to the 1/2, is the same as the square root of a. A to the 1/3 is the same as the cube root. A to the 1/4, same as the 4th root. A to the 1/5 is the same as the 5th root. And in general, a to the 1 over anything, 1 over n, would equal the nth root. So on the next page, there's 3 questions for some mental math. I'd like you to try them, and I'll put the answers up in a bit. Check how you did. Did you get 7? -3. And -2. So probably at this point, seeing a fraction as an exponent doesn't trigger you to think about what this number is. You would probably say, oh, first I'm going to think about the square root of 49, and then you see that and say, I know what that is. That's equal to 7. This one, I'm going to think about the cube root of -27. 3 times 3 times 3 is 27, so -3 times -3 times -3 is -27, and so on. Some other review from grade 9, the power law. If you have a power to a power, the law says, or the rule states, you should multiply the exponents. So just using the rule, this should be x to the 8. Now, I find that for most of my exponent rules, I don't memorize them because I feel that they should make sense. If you know what an exponent does, if you know the definition of an exponent, which is repeat multiplication, then this rule should make sense. Because if I have x squared to the exponent of 4, that means I have x squared 4 times. Of course, it gets annoying to write these out. This is why we have rules to make things shorter. And, well, what does x squared mean? Well, that means x times x. Oh, my goodness. And if I look at this, and I have x times 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 x, well, I could write that as an exponent. That's repeated multiplication of x 8 times. So when we look, we could do this every single time for every single question, but someone says, isn't it easier just to multiply them? It makes sense. It makes sense that you have this 4 times, and each of them is 2 times, so I can just go 2 times 4 and get x to the 8. In fact, all of the exponent laws you learned in grade 9, if you think about what an exponent means, all of the laws should make sense. If you're just memorizing them without knowing why they work, you're going to find you're going to make a lot more mistakes. Whew. So now what does this mean? 4 to the exponent of 3/2. Now the reason I showed the previous law is because this means I can take this 3/2 and I can think of it like this. Would you agree that 3 times 1/2 is 3/2? So if I break up the 4 to the 3/2 as 4 to the 1/2 to the 3, my exponent law says that that's the same thing, because I could just multiply my exponents and get 3/2. But when I write it this way, we can now do our mental math a little bit easier. 4 to the 1/2 is square root of 4. What's the square root of 4? 2. So I could change the inside to be 2, and now I have 2 cubed, which is 8. But right now, someone here is like, oh, I'm so confused, Mr. JR, because doesn't this mean 1/2 times 3? And you wrote 3 times 1/2? I should have written 1/2 times 3. Is that still 3/2? This is not supposed to be crazy, but why should I have written 1/2 times 3? Because I wrote 1/2 first and 3 second. And so someone's wondering, what happens if I wrote the 3 first and the 1/2? Is this wrong? Or does that mean the same thing? Same thing. But our math is going to be different now. Because if I do inside the brackets, what's 4 cubed? 64. And then you have 64 to the 1/2, which is square root of 64, 8. We get the same answer. Whew. That was a little scary. But we get the same answer. You just have to decide, if I have a choice, what would I rather do? Would I rather cube something and then square root it? Or square root it and then cube it? Okay? I like what happened in blue because the numbers end up being smaller. Like I can make another example where this would be very bad to use. Okay, let's go 64 to the 3/2. This is a great example. Oh no, this is still not the best example. Maybe we won't make it such big numbers. Let's just make it 25 to the 3/2. If you did 25 to the 3/2, these are your options. You can either do the 1/2 first and then cube, or you can cube first and then do the 1/2. If you do the square root first, what's the square root of 25? 5. And then 5 cubed is a little bit big, but 5 times 5 is 25, times 5 is 125. If you did the 25 cubed first, what is that? Does someone have their calculator? What is that number? 15,625? And then you have to square root that. All of a sudden you're like, I hope this is a calculator question. It still works out to 125, but you might, the left side you could do with mental math. The right side would be problematic. So yes, they are the same thing, but the order does help us make things easier. So here, 32 to the 2/5. Try it on your own. What is the 5th root of 32? Is there a number times by itself 5 times that makes 32? 2 times 2 times 2 times 2 times 2 is 32. So this becomes just 2 squared, and 2 squared is 4. Check this out. I think this is pretty cool. If 32 is equal to 2 times 2 times 2 times 2 times 2, five twos, Does that look like I've circled 2/5 of it? Isn't that cool? Equal to 4. That's kind of cool. So now you can do stuff like 81 to the 3/4. Well, 81 is 3 times 3 times 3 times 3. It's 27. That's pretty nice. Right? So now, if your parents still ask, what did you learn today? This would be a great one to say, oh, we're doing this. Do you remember how to do this? And then see if they get the right answer or not. They've probably forgotten. So in general, if you have a fraction as an exponent, you can break it up using your power law and then do the nth root first and then to the power of m afterwards. Now, a special note here that I've written is that you have to have the fraction in reduced terms, because otherwise sometimes you can do math that you're actually not allowed to do. You want to see an example of doing math in the wrong way and why it has to be reduced? Illegal math. Here's illegal math. Okay? Here is an example of some illegal math. Because this, first of all, we should do it right just to make sure. So for doing this right, this should become 1/3. And then the cube root of -8. The answer is -2. But if you do this math illegally, okay, so I guess should use a red pen, or are there any colors that are outlawed? No, green and blue are legal. Red is bad, right? You get X's on tests. It's like red. Okay, so I will do this bad. I'm going to do the squared first. Put that inside. Yeah, -8. So I'm going to take the -8. I'm going to square it first, and then I'm going to do the 1/6. What happens when you square a negative number? It becomes positive. So this would become 64 to the 1/6. And 64 to the 1/6 is 2 times 2 times 2 times 2 times 2 times 2. It becomes, my answer is +2. When we did it right, it should be -2. So sometimes if your numbers are not square root or not simplified, you get a problem. Or, also bad, let's say we did this and I did the 1/6 first. And then I squared afterwards. Now, unfortunately, this is bad because there is no number that multiplied by itself. Well, there is a number, but there's no easy number multiplied by itself 6 times. That's 8. So right now, I need you to go to your calculator, put -8 in brackets, and do to the 1/6. And tell me what your calculator says. So just this part, -8 in brackets to the exponent of 1/6. What does your calculator say? It says error. My goodness. We have issues here, right? You know how you're not allowed to take the square root of a negative number? You can't take the 4th root of a negative number. You can't take the 6th root of a negative number, the 8th root, the 10th root, the 12th root, the 14th root, 16th root, and so on, forever and ever. What roots can't you take of negative numbers? Even numbered. So if you have an even number root of a negative number, you will always get an error. So in the note before, it says the exponent must be in reduced form so that you don't run into these problems that show up in this example. So if it is in reduced form, this is the only answer. The answer to this is -2. Because if you don't reduce it first, you run into some problems. You can either get a different answer, or you can get an error that doesn't even work. So one of the things besides simplifying sometimes something's in radical form, and you want to change it to exponential form. So in this case, the fourth root of x cubed, we could take the first step and change the fourth root to an exponent of 1/4, and then use your power law to multiply those and simplify it to be x to the 3/4. So I'd like you to try the next couple. I'll put up the answers in a bit. Evaluate. Did you get 8? Okay, our work, you would do 4 to the 1/2 first, which is 2, and then cube it, and 2 cubed is 8. Convert to exponential form. This would be 2b cubed to the 1/3. And if you used your exponent laws, you could write the 2 to the 1/3 and the b cubed to the 1/3. So this simplifies to just be 2 to the 1/3 times b. Ooh, so much fun math. If I then rewrote this as radical form, can you see that the b doesn't have an exponent anymore? So I could just write this as b cubed root of 2. And this connects to, oh, oops, wrong arrow. I want to connect. That connects to simplifying radicals that we did before. Can you see that you could have taken a b out in front because it was cubed? And now our fractional exponents show us the same thing, which is cool. So much fun math. Evaluate 9 to the 2.5. How did you do? I would have changed this first to a fraction. The square root of 9 is 3. Mental math might be a little hard on 3 to the 5. 3 times 3 times 3 times 3 times 3. And the last one, have we done this one already? No? What happens if I write it like this? Have we done this one already? No? What happens if I write it like this? Did we do this one before? Yeah, this was in our notes before. That was one where I wrote all the 2's, 32, 2/5 of it equal to 4. So at the end here, for the last 10 minutes, we are going to work on some of these questions from the textbook.